If you were in Venice in November 2022, you may have noticed these glass barriers in place. They serve the purpose of safeguarding St. Mark's Basilica from potential flooding. This represents a bold attempt to address Venice's most urgent issue, its gradual sinking, a problem that has persisted for many years. Venice invested a substantial $7 billion in constructing a sea defense system, which finally became operational in 2020. However, as the footage demonstrates, this extensive and costly megaproject is not yielding the expected results. So, what's the underlying challenge? Why does Venice still require additional protective measures for certain areas of the city, despite the substantial investment? And if a $7 billion system proves insufficient to preserve Venice, what alternative solutions are available? People from all corners of the globe flock to Venice to admire its picturesque canals and architectural wonders. But the city's long-term existence is uncertain. In the worst-case scenario, experts predict that it could be submerged as early as 2100 due to buildings sinking deeper into the soil and rising sea levels brought on by climate change. The city gets a foretaste of this impending future whenever high tides, known as acqua alta, inundate the streets. Venice has historically contended with occasional flooding, given its unique location. However, in recent decades, these flood events have become more frequent and severe, exacting a heavy toll on the city. Venice is currently grappling with its most severe flooding in half a century. As locals emphasize, this level of inundation is far from normal, with Venice experiencing flooding dozens of times each year. The glass barriers represent just the latest chapter in Venice's ongoing struggle to fend off the encroaching waters. The city essentially rests atop a lagoon, with its foundation primarily composed of mud, making it highly susceptible to the whims of the sea. The first settlers lived in houses made of wood and clay, both fairly lightweight materials, but as things expanded, better engineering tactics were needed. To create a stronger foundation, long wooden piles were driven into the ground until they reached hard clay 5 to 6 meters down. Each pile was closely placed together, with rock packed in between, which prevented the silt from rising. From here, wooden platforms and stonework were placed on top. That worked for a time, but by the 16th and the 17th centuries, the constant flow of sediment from the main rivers flowing into the lagoon had essentially turned it into a swamp. To solve that issue, engineers boldly diverted the rivers around the lagoon and straight out to sea. Just a couple of hundred years later, the barrier islands that divide Venice Lagoon from the Adriatic Sea were reinforced with a 10-kilometer seawall in an attempt to withstand storms. Then, following the devastation of the 1966 flood, the city installed a network of raised walkways of 110 centimeters. But as you're probably guessing, none of that has been enough, and Venice has had to make a much bigger and more innovative investments. What you're witnessing here is the city's latest and most expensive flood defense system to date, a mechanized barrier named MOSE, with a price tag of $7 billion. MOSE promised to offer salvation from the constant threat of flooding. After decades of controversy and meticulous planning, it finally became operational in 2020. Here's the intended functionality of MOSE. A series of 20-meter-wide metal barriers have been strategically positioned around the lagoon's entrances. These barriers are situated within substantial concrete caissons that are pre-manufactured on land and then lowered into trenches on the seabed. Each of these massive concrete sections includes a service tunnel, all interconnected with the mainland, providing access for inspections. When not in active use, the hollow barriers are filled with water and submerged beneath the surface. However, when a high tide is predicted, compressed air is introduced into the gates, causing the water within to be displaced. This action leads to the gates pivoting on their hinges and rising above the water surface, effectively blocking the incoming tide from entering the lagoon. Subsequently, when water levels recede, the gates are refilled and descend below the surface, allowing ships to pass through. Over the past few years, MOSE has successfully prevented numerous potential flooding incidents that would have previously inundated the city. Nonetheless, it has some limitations. To begin with, the construction process was exceptionally time-consuming. Initially designed in the 1980s, it was intended to become operational in the 2010s, but it didn't actually go online for another decade. During this time, our understanding of climate change and its anticipated impacts have evolved significantly, rendering the scenarios for which MOSE was constructed outdated. As a result, certain parts of the city still experience flooding, such as St. Mark's Square, which transforms into a substantial body of water whenever the tide exceeds its regular level by more than 80 centimeters. Unfortunately, city officials only activate the MOSE system when tides reach 110 centimeters or higher, providing protection to approximately 86% of the city. Lowering this threshold would necessitate the gates to be closed 80 to 100 times a year, a frequency the system is not currently equipped to handle. This is why, despite the implementation of a new $7 billion system, Venice still relies on additional flood defense measures, like these glass barriers. These glass barriers are approximately 5 meters in length and stand at a height of around 1.3 meters. They serve the purpose of preventing rising tides from inundating renowned buildings. Each barrier is securely affixed to armored concrete that extends 2 meters beneath the ground surface. They operate in conjunction with a network of pumps and valves designed to prevent blockages in the drainage system. When there is no flooding, there are openings in the walls. However, when the tide approaches, these openings are sealed off. This is intended as a temporary solution until a more permanent one is developed. These walls and pumps have the capability to hold up to 1.1 meters of water, a task that MOSE is not yet optimized to perform. Yes, you heard that right. The $7 billion MOSE system cannot match the effectiveness of the straightforward glass walls. So, after delving into all this background information, you might be wondering why they don't simply lower the flood threshold and activate MOSE more frequently. Well, brace yourself, as one of the primary reasons is the high operational cost of MOSE. Each time the barriers are raised, it incurs a cost exceeding $320,000, primarily allocated to power consumption and the deployment of teams of individuals. Approximately 80 personnel need to traverse the lagoon to be on-site for manual maintenance and operation of these machines, including air pumping and other tasks. So it's not just a matter of pressing a button, it involves deploying a team of 80 people who may need to remain on-site for extended periods, especially if there are adverse weather conditions that prevent their return. To clarify, MOSE is not yet fully completed, and it's likely that the operational costs will decrease over time. Technically, it's still in an experimental phase and is expected to be fully operational by this year. In the future, it may be optimized to require a smaller crew, enabling it to be activated more frequently. However, this does not necessarily imply that it will be utilized more frequently. Additionally, it's essential to remember that when you close off the lagoon, no ships can pass through. This includes industrial ships, passenger ships, and commercial vessels like fishing boats. They would be unable to enter or exit the lagoon. Since 27% of the city's economy relies on these ships, mitigating floods also means reducing income from trade. While the system incorporates locks alongside its gates to permit some ships to pass, it significantly impacts overall capacity. To compound matters, MOSE is not a permanent solution. George estimates that the system might be pushed to its limits around 2050 or 2060, depending on the rate of sea level rise and how frequently the gates need to be closed. He believes there are more effective long-term options that the city could pursue, such as elevating structures above sea level by utilizing underground wells to pump water away. There are geologists who have been involved in similar projects, and they have demonstrated the possibility of raising Venice by approximately 30 to 35 centimeters. When sea level measurements were initiated at the end of the 19th century, the average water level was established as 0. So if Venice can be elevated by 30 to 35 centimeters, it essentially reverts to a state equivalent to 120 to 140 years in the past. This method of raising land has been under consideration by scientists for some time and has been implemented in other locations like Taipei and Tokyo to counteract sinking and for gas storage. However, the likelihood of seeing this approach applied in Venice in the near future is minimal. Critics argue that because the city invested so heavily in the MOSE system, it is the one they will have to rely on, at least for the time being. Nevertheless, this perspective may have to change if the city's very existence is genuinely threatened by rising waters. Venice, this magnificent city, has been contending with the forces of the tides that have contributed to its prosperity for centuries. It has often utilized engineering solutions to navigate its relationship with water and find a way forward. However, in a world where change is happening at an unprecedented pace, Venice is realizing that billions of dollars and temporary solutions like glass barriers are no longer sufficient. Consequently, one of our planet's most awe-inspiring cultural landmarks finds itself in an increasingly desperate race for survival, a race that it appears to be losing. If you like this video, please subscribe to the channel and feel free to share your opinions in the comment section below. Thank you for watching, and we'll look forward to seeing you in the next video.